Hello, everyone. Welcome to today's webinar on requirements engineering. My name is Simon Brereton, and I'm going to be your host today. I work for ITonlinelearning, and I am a business analysis tutor. So today's topic is on requirements engineering. It is first easy for us to see that before we create anything complex, we need to know exactly what the features of it are going to be. You can imagine we can't build a car, for example, without detailed designs and manufacturing specifications. We also can't build a house without detailed plans and building specifications. Could you imagine what would happen if they didn't have these documents or these plans or these specifications? If the engineers or the engineers and manufacturers of the vehicles or the builders of the houses did not have these specifications, the house simply would not be able to be built, or the car would not be able to be created. We simply need to know what needs to go into these products before we can actually build them. What we can say is that we need to build anything complex, we simply need clear documentation that outlines the specifications and features of what needs to be produced. This is also true in the field of software development or system development. So for the software developers that are building software development or IT systems, need to know exactly what needs to go into the system for them to build it. What will happen is these specifications will basically outline the features of a software product or the system that is being built. And this is where the requirements come into play. These features or these details that we are putting into our software product are known as the requirements. And we need to gather these requirements before any software development can take place. What we can say that in its basic form, each requirement is simply a statement about what needs to go into the system or what features need to go into the system. If we imagine a software team or a web development team that are building an e-commerce platform, and they have some requirements that have stated that the system, or they've elicited some requirements that state that the system shall allow the user to search for a product, or the system shall allow the user to add a product to a shopping cart, or the system shall display products on a product page. We can see these three requirements for the e-commerce system here. These are short, simple statements about what the system needs to do. They are quite clearly stated, and there's no additional information attached to them that makes them unclear. These are the requirements for the system. But you can imagine that a system can't be developed on these three simple requirements. We would need a much longer list of requirements so that the developers know exactly what the system is supposed to do. We can also see here in the slide that requirements can also be for a specific user. These first three requirements are for the users of the system, which are the customers. So these are the customers that will be browsing the products in the system and actually making purchases. So those three requirements, which are the system shall display all the products on a configurable page, the customers need the products to be displayed on a page for them to be able to select the products and make a purchase. The system must also allow a user to select a product to configure. So the e-commerce system itself may have defined that the products that are being sold are configurable products. So when the customer, the user of the customer is actually selecting a product, they then may need to configure items such as select the color of the product or the size or the quantity or something like that. Now, the third requirement here for the customer is the system shall notify the user of misconfigured products. So if there were situations where the products weren't available or something, they haven't configured the items in the product, this requirement here, this statement is telling the developers that the system must notify the customers that the products have not been configured correctly. So they may need to go back to the system and select the right configuration items. So there are three other requirements here which are in this list, and these are: the system shall display all the products on a configurable page, or the system shall allow a user to select a configurable product, or the system shall notify the user of misconfigured products. So those are the three requirements that are for the customer, for the user that is using the system as a customer. So there are also three requirements here which state that the system shall allow a user to search for product items, the system shall allow a user to add a product to a shopping cart, and the system shall display popular products on a product page. So these are also all requirements for the customer user. Okay, so to get these requirements for the new system, we need to carry out the process of requirements engineering. This is a process that we need to follow to extract these requirements from the users or whoever has the information about the system as to what it's going to be doing, such as the features. And another thing that we also need to understand, to go back to these requirements here, that requirements can also be for different users of a system. So we could even imagine that the requirements for a senior manager it might even be not even related to that of the system itself. It might just be some hypothetical requirements, such as, well, which we call a general requirement, which would be more on a strategic level. So it would be the senior users might be asking that a new system should be built, and it needs to be designed to modern user standards and possibly follow out the corporate identity or incorporate the logo of the company. So these are not related to a specific user, but they are also requirements for the system. But they are just not defining the specific features of it. So what we need to end up with is a clear list of what needs to be included in a system. And this is usually done, or this is usually extracted from people that know the system, such as the users. They might be staff in a business, they might be the customers, they might be the developers, they might be even the managers themselves that know the system quite well. But what we can say is that those that define the system documentation, such as the business analysts or even the developers, are the people that are going to be carrying out the requirements engineering process. They are going to be the ones that are going to be extracting information from users. They are the ones that are going to be talking to people that know the system and ultimately getting a clear list of features or statements about the features of the new system. So here we can see we have the stages of, or we can say that the requirements engineering process has stages, but they don't quite follow a sequential process, which we'll look at later. But these are the parts of the requirement engineering process, which has 5 parts, which is to elicit, analyze, document, validate, and manage the requirements. We're going to be looking at all of these 5 stages or parts of the requirements engineering process. But ultimately, all of these steps or these aspects of requirement engineering are needed to define requirements for a system effectively. So let us have a quick look at each of these aspects of requirements engineering to deepen our understanding of it. So the first part of requirements engineering is requirements elicitation. Elicitation of requirements can be seen, well, requirements elicitation is a large part of the requirements engineering framework. It's the part where we are going to these stakeholders of the project, or these people that know the system, and extracting information from them, and ultimately defining these statements and these requirements for the system. So what we need to do is we need to aim to identify and first identify the requirements for the system and gather them, and then ultimately get to a point where we can document these requirements. But this is what takes place through the other stages of the requirements engineering framework. The requirements elicitation phase is about extracting information and about gathering the requirements for the system. So the people that will be usually extracting information we might start with those that have sponsored the development of a new system or project, such as senior managers or executives. These people would have quite a broad knowledge of an older system or a new system that we want to produce. Because sometimes in software development, or the development of any product, or complex product for that matter, we need to understand what the purpose of the system is in the first place. And we start with the managers, or the senior managers, the executives, those that are high-level view of the system. And these are often called the general requirements. So what we have said before, this is where they would extract, I suppose, corporate identity, branding, guidelines, and things like that, and basically define the purpose of the new system. And these people at this higher level would also then be able to indicate where we can move to defining more specific features of the system, such as the functional, non-functional, and technical requirements. So you can imagine that we've now gone to a senior manager of a particular department in a company, and that manager has said to us, this is what the system in its basic form needs to do. And now you need to go, well, the senior managers could then identify that who the users of the new system are going to be, and who are the people that know the system well. So these could be people such as the administrators of the system, so potentially using a back-end process. They could be people, staff that work for the organization that are in a particular department, such as if we were building the system for a customer services department, we would then go to the customer services representatives, and they would then be able to show us how they use the system. So they may follow out a particular process or a particular sequence of steps that they do on a system. And through this process of talking to them and carrying out investigation techniques, and such as workshops and interviews and shadowing techniques, we would then be able to define what these requirements for those specific users are. Now, there may be other users that may not be easily contactable, such as the customers that are also users of the system, but they may also offer us insight into what their requirements are for the system. And we would then need to formulate a method or a methodology of extracting information from them during this elicitation phase of requirements engineering. We could use techniques such as surveys and questionnaires. So if we had a list of all the customers on the system, we could send out a broad email to them, or a survey, where we would then get feedback, and they may be able to also provide us with information about the requirements of the system. So we can say that we'll be extracting information, and defining the requirements for the system by talking to users and communicating with users of the system, as well as anyone that has knowledge of the system or the software product that we're building. So the elicitation we can say that the elicitation of requirements can be done using various techniques such as interviews, workshops, surveys, and focus groups. And this first round of elicitation will gather the general requirements at a high level, as well as capture the initial functional requirements of the system. So we'll look at this example where the initial requirements, an initial requirements elicitation session has been set up, where potentially a business analyst has gone into the organization to start extracting information to help to get to a point where they understand the system and gather some initial requirements. So these first requirements that are coming onto the list of our list of requirements for the system. So this large company potentially may have a customer services department, and let's say they've been using a software system in this customer services department to log complaints and communicate with their customers. And they've been using the system for a number of years. So the customer services representatives have been communicating with the customers, and the customers have been logging the complaints using the system, and it's been working quite well. But let's say that the system that they've been using for several years has now come to a point where the system is now outdated and it's starting to produce errors. And let's also say that we've got to a point where there are now advancements in technology and that allow the systems that are being used by other organizations to do much more than the current system is doing for this organization that is using it. So these advancements these advancements to a system, or this ideology that the system is going to be improved by either developing a new system or finding a new system that can be configured for this customer services department, we could say that the motive or the purpose of creating this new system would be to speed up their processes and reduce these errors that are taking place in the system, and ultimately make the organization much more efficient at what it does. So we can imagine that the executives of this organization or this company have now decided to build this new system. Let's say they haven't been able to find a system that can be configured to their specifications as to what their customer services representative staff do for their particular industry. And they now need to build a new system that is free from defects and will also have features that are in line with modern user standards, that have all the advancements in the technology at this point in time. So the organization potentially gets a business analyst then to do this requirements work or this requirements engineering work for the project. And this analyst then starts interviewing the executives and the senior managers of the company to get these high-level requirements. And at this stage, the executives may not be able to provide them with the specific requirements for this whole system, but they'll just give these general or overview requirements, what the system needs to do or needs to look like, or what the purpose or objectives of implementing this new system is. So this is a very beneficial part of this requirements elicitation process, because it provides a context for the development of the system and also aligns the needs of the organization with the development or the implementation of this new system. So during these initial interviews with these high-level staff, they may also be able to give the analysts insight into where further requirements can be gathered. So what we had said before, they may give us information such as the contact details of the users of a system, or they may guide us towards the departments that will be using the system. They'll be able to potentially give us a contact list of the users of a system where we can send out surveys and questionnaires and such. So they may even sort of, if the organization had potentially built the system using an external, it had outsourced the work to a development team, they then could also point us in the direction of this team so that we as a business analyst could then go talk to the developers of the system, and they could give us system documentation about the old system, so we could then potentially sift out all of the information that we don't need in the new system, and then the information that we do need to help us gather the requirements for the new system. So in our example, the users of the system are the customer representatives themselves and the system administrators, as well as the customers. So the analyst would, once they've done this initial elicitation, so they've gone to these users of the system, they've spoken to these members of staff, they've now started getting an idea of what the new system should do, and they've started listing these requirements in a statement form. So the system should do this, and the system must do this, and the system mustn't do this, or the system needs to store this information. So what we are doing here is, in this elicitation process, is we ultimately working towards getting a clear, definitive list of what the system should do. But in the early stages of elicitation, it will be more difficult to do this. So the analyst would then need to set up further elicitation sessions in order to gather more requirements or validate information. But this is what we'll also show you in this requirements engineering framework, that these will be part of the other stages of this requirements engineering framework. So the next two stages, or the next two aspects of the requirements engineering framework, is the analysis and documentation of requirements. So the reason why we need to analyze requirements that we have gathered from these individuals, to ensure that the requirements that we've gathered are not incorrect, or the initial list may also show us, this analysis may also show us that the list that we've documented or we've gathered and listed is incomplete. So this is where the analysis of requirements comes into play. It's a stage that takes place after elicitation. So we looking at the information, we're looking at these statements of the features of a system, and we are looking to see what has gone wrong. Are there requirements that are duplicates of each other? Are there requirements that shouldn't be brought into the new system? Are there requirements that are ambiguous? Or, so when we've produced the requirements documentation at the end, we don't want to give requirements that don't make sense to the developers, because we don't want the developers to come back to us once they've actually initiated the development process and say, look, guys, these requirements that you've given us here, we don't quite understand what you mean here. We can see that this requirement looks like it's related to this one, but is it really related? You can imagine in a software system or any kind of complex system that's being built, you would end up with quite a long list of requirements, and these need to be clear. It's said that they need to be clearly stated, unambiguous, and correct. So we can't have any incorrect requirements going into the documentation process. So this is why we need to analyze the requirements. So we need to analyze them to ensure that they are suitable to hand over this requirements document to those that will be building the system. And we won't need to do further work to clarify what these requirements are. So during a requirements analysis, we can say that the requirements analyst will identify gaps, ambiguities in the requirements, and identify where misunderstandings have occurred. So if we now go back to the requirements engineering for our customer services example, we can imagine that the analyst has elicited requirements from one of the customer services representatives. And he has stated that he wants the system to notify the customers when a ticket has been closed. And the analyst may have spoken to a different customer service representative who has stated the system shall send a message to the customers when a query has been resolved. Now, if you look at these two statements here, these two requirements for the new system, we can see that although these two individuals have stated these requirements slightly different, we can see that they are extremely similar. And through an area of analysis, we may even define that these two requirements are exactly the same. So a developer may have taken these two requirements as two separate requirements and built different things into the system. So they need requirements need to eliminate any aspects of ambiguity or any areas where they are unclear. So each requirement on a requirements list, we can say, must be unique, clear, and unambiguous for the developers to clearly know what must be built by the system. We don't want to produce a document where when the system has gone into development, the developers themselves have to clarify what the system must do, or even worse, make an assumption and build the wrong features into the system. And can you imagine how much time, effort, and cost goes into some of these complex projects that are being built by organizations? Can you imagine incorrect features that are built into a car, for example? Can you imagine the incorrect features that are built into a software system or into anything complex? You can imagine that it would just be a wasted effort if those requirements had been included in a list that had been produced by an analyst and the developers had now made their own assumptions about what the system must do. This is why the requirements need to be clear. So we can say that there are numerous reasons why requirements can go wrong and why there needs to be a stage of requirements analysis. An analyst needs to know all the techniques for analyzing requirements appropriately, such as the application of requirements filters. Requirements filters will eliminate a range of problems with requirements. So you can always see that these requirements that we've initially stated, we'll then look at each of these requirements using these filters to see if potentially the requirement has been incorrectly stated. Is it a duplicate requirement? Is it something that cannot even be completed by the developers? Is it presenting a solution rather than defining what a feature of the system is? But these filters will help us to eliminate any requirements and clarify our list of requirements for the new system that is being built so that the developers will have a clear idea of what they need to do. So there are also a range of other activities that an analyst may also do doing requirements analysis, such as categorizing the requirements. So here, during the categorization of requirements, we need to place the requirements into their different categories. Because as we've said before, that we had requirements that had potentially been elicited from the senior management or executives, which were the general requirements, which weren't specifically related to the features of a system, but they still need to be categorized as such, because you can imagine that if some of these requirements just happen to end up on a list as a requirement for the system, or functional requirement or a non-functional requirement, then the developer would then end up building something that is incorrect. So there's ultimately 4 categories of requirements, which we need to place the requirements in. We have the general requirements, which are those that are just stating the purpose and the corporate identity, the branding, things that are not very specific to the functionality of the system and exactly what needs to be done by the developers. We also have the technical requirements, which outline hardware specifications and requirements. Then we get into two further categories, which are usually elicited nearing the end of the requirements elicitation process, because these are the functional requirements and the non-functional requirements. And these are the actual requirements which define what the system must do and how the system should behave. So this is where this is why we need to classify requirements into their categories, so we can separate them out, and the developers will have a much clearer understanding of sort of what the purpose of the software system needs to do, how it must be built from a technical perspective. And then in terms of the functional requirements, this is exactly what the system must do. So it's the detailed features of the requirements. And then the non-functional requirements are also specifics of the system, but they're not related to the functionality. The non-functional requirements would specify sort of accessibility or security requirements. So you could imagine that if the new system had to process a whole bunch a whole lot of information, such as store user information and contact details, there may be requirements that specify exactly how that information is supposed to be stored. And these are usually classified in the non-functional requirements category. But this is another part of the analysis of requirements, is the categorization of it. So you can see that we're taking requirements and we're not only processing them using filters, but we slowly getting a better understanding of the requirements and getting us to a stage where we can list very clear statements of what the system should do. So during this analysis stage, we may also carry out the modeling of requirements. So here we may map out what the requirements are going to be doing on a system, create sort of UML or class models, entity relationship models and such, which will show us in a visual representation format that this user will be doing this on the system. And when this happens, then this will take place, such as if a customer places an order, then this order will then be handled by a customer, rather a sales representative, if that was part of a sales system or an e-commerce system for that matter. So during this analysis phase, we'll also be modeling the requirements to help us understand what the new system is to do. Slowly get to a stage of where we can produce clear documentation for the developers. And we'll also use these models to go back to the users or the stakeholders that we've initially elicited the requirements from. And we will these models will help them understand the system and understand what we want to extract from them in terms of what the system must do. So the modeling will give us a visual perspective on requirements, on the requirements, and this will be also conducted during the analysis phase. There's another activity that we'll do during analysis, and that is the prioritization of requirements. Here we need to take the requirements that we have elicited, so we've gathered these requirements, and then we need to define which are high, medium, and low priority. Or we can even use other prioritization techniques, which will help us define which requirements are most important, which are not so important, and which are not important at all, or of very low importance. And by classifying requirements in terms of their priority, will also help developers prioritize their work and decide what needs to be developed first to get the system to a point where it's functioning effectively. So you can imagine there's a requirement that that has been stated that a system must do a very specific thing, such as a customer needs to make a purchase on the system, or there may be requirements such as the system needs to be designed in a specific color or use a specific font. And then we may prioritize that the system, there'll be much more of a higher priority placed on a requirement that is that is related to the functionality of the requirement, because maybe the color of the system might not be such a high priority to us or to the developers. So you can imagine that the system may not even be used by a customer-facing user, or the system may not even be used by anyone that really needs a system to look a certain way. So if they are administrators that are accessing the back end of a website, such as the administrators of a system, the priority on the color of the system may not be so high. But this is just an example of priority in terms of requirements. But we'll take all of the requirements that we've elicited and we'll prioritize them. We'll define which ones take precedence over others. And we will define that in our requirements document so that when the developers are developing the product, they know what to do first, or they know what to focus on, because they may get to a point where they might run out of time. And then they might define that, look, guys, these requirements that you've stated here, you've said that they're low priority, and we're just going to leave them out of the system for now, because we've gone over budget and over time. And the organization there may be an imperative to have the organization use the system in a shorter time frame. So we can say that prioritization is also a part of analysis. So all of this analysis work will ultimately culminate in the documentation of requirements. So we know that we've gathered the requirements, we've now looked at the requirements, modeled them, prioritized them, understood them. Now we need to actually document them. We need to put them into some form of a documentation that is going to at some point be handed over to the developers. This is where the documentation of requirements comes into play. So there are different documentation approaches when it comes to the documentation of requirements. Some organizations may require a formal detailed business requirements document, or a BRD. And this BRD may include processes, system models, a requirements catalog of much more detailed information about the requirements. Okay, so we can also say that in terms of documentation, other organizations may require that, may just need a simple list of all the requirements that are to go into the new system. And some organizations may just need a spreadsheet or an Excel document. And there are other ways of documenting requirements which are commonly used, and this is by using a software application. So this is a tool where all the requirements can be cataloged, can be prioritized, can be documented in this online software application, where various users would be able to access this system and be able to see what the requirements are. And requirements can then also be manipulated in the system in real time, so that everyone can see what is actually going on with the requirements, even during the development process when using sort of agile approaches. But there are systems out there called Jira. You may want to have a look at it. It's a very, very beneficial system not only for requirements engineering or for documenting requirements, but it's extremely beneficial as a project management tool or managing tasks and such. But we as business analysts or as developers would use a tool like Jira to digitally track, monitor, prioritize, and distribute our requirements to the developers. So in short, we can say that analysis is the stage where the requirements that have been gathered in the elicitation stage are analyzed, refined, and organized into a structured format. And the goal of this stage is to ensure that the requirements are clear, complete, and consistent. And the documentation of requirements is where the requirements are written down and captured in a clear and concise manner, so that we can clearly understand that it can clearly be understood by the development team. And this can be done through the requirements document or a requirements management tool such as Jira. So the next part of the requirements engineering process is validation. It's requirements validation. Here, the goal is to verify that the requirements are correct and complete. And this is done by going back to the individuals and groups that have information about the requirements to clarify that what has been documented and analyzed is a true reflection of what is to be built into the system. Here, once again, the analyst may carry out reviews, walkthroughs, and testing activities. They may use models, prototypes, designs, mock-ups, and wireframes. So here we can imagine that we have a group of stakeholders that we've elicited the requirements from. We may have analyzed them, we've documented them, but now we need to go back to these individuals and groups and let them clarify that what we have stated for the new system to do is correct after analysis. And we may even need to go back when we've actually found discrepancies or incorrect items in our requirements list, and go back to those people who we initially elicited the requirements from and say, look, this requirement that you've told me, this feature that you've told me that the system must do here, it doesn't quite work. And then the person might say, oh, well, you're actually quite right. I'm so sorry. I wasn't thinking correctly there. This is actually what it must do. You know, so you can almost imagine this process of validation is to help them understand and clarify that what they have said is the correct thing, is a correct representation of what the system should do. And this validation, and by using models, prototypes, designs, mock-ups, and wireframes, even scenarios, this will help these stakeholders to visualize the new system and clarify the understanding of how the new system should be designed and how it's supposed to function when it's used in the operational environment. So the final element or stage of requirements engineering is requirements management. So this management stage involves monitoring, updating, and tracking the requirements throughout the project. And this helps us to ensure that the requirements are aligned with the project goals and that the final product meets the needs of the stakeholders. So we can almost see management as an ongoing process where we're looking back at the requirements to ensure that they are correct, to ensure that they're being tracked effectively, and also to see that they have been updated, because we're going to ultimately develop a large list of requirements throughout this whole engineering process. That information needs to be managed carefully. You could imagine that a requirement that we potentially have elicited and deemed to be a correct reflection of what the system should do. We may have elicited a different requirement at a later stage, which now conflicts with that requirement, and it now invalidates the requirement before. So we need a formal process for managing, monitoring, and updating and tracking these requirements throughout the whole project. This is from the point that we start eliciting the requirements all the way to the end of the development, the development process when the system is finally built and is released into the operational environment. And this helps us to ensure that requirements are aligned with the organization's goals too. So that covers the requirements engineering process. We also need to understand that this process here is following a format that is more inclined to a linear or waterfall project. But we also need to see here and understand that this requirements engineering process does not follow a specific sequence of stages as what you can see in this slide. It actually follows a very disjointed or iterative process. You can imagine that sometimes once we've elicited the initial requirements, we may need to analyze those requirements and then document those requirements. We may be documenting the requirements before we analyze the requirements. We may need to validate requirements during a second elicitation session before we document the requirements. And throughout this whole process, we also need to manage the requirements. So it is not a 5-stage process and then the requirements engineering process ends. It is more of an iterative or a disjointed format, as you can see here rather in this slide, where it's going between all of the different phases or stages, where it's jumping from one to the other. So we also now need to understand that there are different approaches to requirements engineering. And as we have said, that there are some organizations that may take one approach, and there may be organizations that take another approach. And usually this is defined at the beginning of the project when they decide how the system is going to be built. So is it going to be built using a linear project lifecycle or a waterfall project lifecycle, or is it going to be built using an agile project lifecycle? This elicitation process here, or this engineering framework, is more inclined to a linear or waterfall project lifecycle that generally takes place where the project is built in predefined formal stages, and the system and everything about the system needs to be defined in detail before any development work takes place. So we also have the agile approach to the development of a project, which is a very, very popular approach when it comes to software development. And the process of requirements engineering here is somewhat different. In an agile project, the process of requirements engineering will take place on an ongoing and iterative process throughout the project's life cycle. So in a linear project, the requirements are usually defined in a very formal document right at the beginning, so that the developers know how to build the system. And then in an agile lifecycle, the requirements are not very clearly defined at the beginning, and they change and evolve as the project takes place. That's the agile way of doing it. So we can say that instead of defining all the requirements up front, agile teams work in close collaboration with stakeholders to incrementally discover and validate requirements. So let's just have a look at how just formally look at how the requirements engineering process takes place in an agile project. So requirements discovery is where the team starts by understanding the stakeholders' needs and goals. And here they capture the high-level requirements through conversations and workshops. It's similar to what we have stated before. They would be going and talking to people, getting the high-level requirements first, creating workshops, interviews, and such. And and starting to gather the requirements. But the objective here is not to get a very definitive, clear set or a definition of what the system exactly is to do. It's more to just get a basic representation of what they are to do. So after this, the requirements are then prioritized, which are based on the stakeholders' priorities and the team's capacity. Then in each iteration, the team takes a subset of the high-level requirements and refines them into more detailed and actionable user stories. So they then become what is known as a user story, which is a different format of a requirement, but that is used in an Agile project. It doesn't say the system shall do this. It says, I, as a user, want the system to do this. But it's just a way of sort of making the requirements less formal. So the refined requirements are then demonstrated to stakeholders, and feedback is then incorporated to validate and refine the further requirements. So we can see this validation process then coming in here. The requirements are refined, and the feedback is based on the stakeholders themselves. Then the requirements that have been seen to be ready are then delivered to the development team as part of a product increment in a release. So in Agile, it follows a cyclical process, a development process where they aim to develop one thing, then go through a review process, and then develop another part or evolve it as they move forward. But the requirements will be chosen in the first release, what is going to be going into that cycle of development, and then it will be built into the system. Then after the next review, the requirements will be reevaluated, and then the process continues until the system is built. So this also encourages stakeholder engagement and collaboration throughout the project, which helps to ensure that the final product meets its needs. So now we've come to understand the requirements engineering framework and what needs to go into requirements engineering and how it takes place in both an agile and a linear or waterfall project. So there's different approaches to requirements engineering based on the context of the project. So we now summarize the activity. Let's summarize the activity of requirements engineering. And we can say that in the world of software development, requirements engineering is a crucial aspect of the development process, as it acts as the foundation for the entire project and establishes the features of the system to be built. If the requirements are not well understood, defined, and communicated, it can lead to costly mistakes, communication, and rework later in the project. So now that we've covered a little definition of requirements engineering and the different stages of the requirements engineering framework, let's just cover some points that highlight the importance of requirements engineering in software and product development. So we can see here that requirements engineering ensures that the needs and expectations of stakeholders are well understood and defined. The development team is also then clear on what needs to be delivered. The risks are identified and addressed early in a project. Change requests are managed in a controlled way. And the final product meets the needs of all the stakeholders' expectations. Okay. Now what we're going to be doing is we're just going to be having a look at this video with an interview from Elon Musk. And here we're going to see how in his teams and in his product development, building cars for Tesla, where requirements, where the context of requirements actually took place here. So he's talking about requirements for his Tesla car vehicles, but he's also indicating here where it's gone wrong. And the reason why it's gone wrong is because there wasn't an effective requirement engineering process that was embedded in his team at that particular point in time. So he actually highlights the need for requirements engineering here. But let's have a look, and during this video, try to identify your understanding now of requirements engineering. Try to identify those features and identify how it takes place in what Elon says here.
Yeah, so, well, I've got this like first principles algorithm that I find to be very helpful in the design and manufacturing of anything. And people here may find it helpful. The first thing you should do is make the requirements that you've been given less dumb. Whatever constraints and requirements were given, they were to some degree dumb, and you want to make them less dumb. If you don't start with this, then you get the right answer to the wrong question. And the requirements must be given from a person who can explain the requirement, not from a department, because then you don't know who to talk to. Then step 2 is delete the part or delete the process step. This sounds extremely obvious, and yet over and over again we have found that parts were not needed. They were just put in there just in case, or by mistake, or there was a step that someone thought was needed but was not actually needed. This sounds insanely obvious, but we've deleted so many parts from the car that did nothing.
They were just there?
Well, yeah, I mean, I can give you so many examples. One example was there were 3 fiberglass mats on top of the battery pack. They partially covered the battery pack, and I was on the battery pack production line, and it was the #1 thing choking battery pack production with gluing on these 3 fiberglass mats to the top of the battery pack. And so this is the reason I repeat this algorithm myself, is that I first did things backwards. First I try to automate it, then I try to accelerate it, just have this go faster. Then I try to simplify it, and only then did I delete it. Because it turned out that the team at Tesla that does noise and vibration minimization, so making the car quiet, thought that the fiberglass mats were there because of the battery safety team for battery fire prevention. And then I asked the battery fire prevention team what were they needed for, and they said, oh, noise and vibration. And I'm like, okay. So then we had 2 cars drive, one with a microphone in each car, and you could not tell the difference. So we went to all that trouble for a part that should not exist. And then another example was there was again, this was these were choke points in the entire production system. That's why I'm running around the production line trying to fix the production line, just like a maniac, sort of Tasmanian devil, just running around the factory like a lunatic. Let's see, we had the body production line in Model 3 was at one point stuck because we had a laser welding cell to weld a small cross-car beam in the passenger footwell of the front seats. And I'm looking at this beam, and I'm like, what the heck does that do? Because the entire factory is stopped trying to get this laser weld cell to work. And I'm like, I can't imagine what a useful thing it could do. And then the production team said, oh, that's for crash safety. So then I called the crash safety team and said, is this for crash safety? They said, oh no, that didn't do anything, we should delete it. That turned out to be totally useless, but they forgot to tell the production team. Honestly, a bunch of these things just feel like you're living in a Dilbert cartoon.
Okay, so we can see here that it's very obvious that at Tesla, they weren't using a very formal requirements engineering process for the development of their cars. And if they had clearly defined the requirements in the first place, I think they wouldn't have run into all these problems that Elon has mentioned here. And there's also a stage in this video which is interesting, where he says that he was going between different people, talking to them about the requirements, going to the different teams and things. And this is even during the development process. So ultimately, he was acting as the business analyst, or whoever the person was that was eliciting or engineering the requirements. But it seems like there wasn't any formal process or any system that was being used, such as an online tool. And there wasn't a high degree of importance and focus on the requirements. And I think if there had been more focus on requirements engineering, then Elon wouldn't have ended up feeling like he was in a Dilbert cartoon. We are now coming to the end of our session. If Elon, we can also see that in that video, that Tesla probably would have saved a hell of a lot of time, money, and effort if there was much more of a focus on the requirements. And this is true for all our requirements engineering processes. If this highlights very clearly the importance of requirements engineering, especially in complex projects. So we can come to a conclusion now that requirements are ultimately a crucial aspect of software development and other areas of product development, such as even in the manufacturing of cars, where there is a need for a complex product to be built. And we need to follow a formal requirements engineering framework, or place some importance on the engineering of the requirements to ensure that there is a foundation for the entire project, and ensure that the features of the product or the solution are clearly defined. And those that are building the solution will know exactly what to do and not waste time and effort doing things, going back to stakeholders and trying to find out what the system should do. So by following a structured approach to requirements engineering, we can ensure that the final product meets the stakeholders' needs and expectations, and that a project is delivered on time, within budget, and with a high level of quality. So I just want to thank you very much for joining me today, and I hope you found this webinar useful or a little bit informative, and you've learned a little bit about requirements engineering. And if you have any questions about requirements engineering, or what is needed to become a business analyst and become a formal requirements engineer, then feel free to post those questions on any of our IT Online Learning social media platforms, and we'll be sure to answer those questions for you, to give you some more information. Or you can even reach out to our course and career advisors, which are experts in the field of business analysis and career development in these fields, and will provide you with much more information on how to get into a career as a business analyst or in a field of work where you'll be carrying out requirements engineering. So yeah, they're more than happy to talk to anybody about their careers and courses and things like that. So I hope you have a great day, and I hope to see you in the next episode, and take care. Cheers, bye.